For our notes today, we're going to talk about one final method for solving systems of equations. When we have two equations, they can be written in lots of different formats. And it's going to be easier to do one method versus another, depending on how the equations are written. We might not have a graph handy to do it that way. So we're going to learn a variety of ways to solve it. We've learned substitution, graphing, and today we're going to learn our third method, which is called elimination or linear combination. But before we do that, I'd like to take us down memory lane a little bit, like to elementary school. And you guys remember when you would solve problems like this, like 321 plus 436. You guys remember what you did? That's right. We just added each column. 6 plus 1 is 7. 2 plus 3 is 5. 4 plus 3 is 7, right? Add each column. Well, this strategy, elimination, also known as linear combination, uses the same idea. So if you look at this system of equations, it'd be a little bit messy to have to get one of the variables alone. I'd have to add or subtract, and then I'd have to divide, and I'd end up with some fractions. It's not the most efficient method. When you have the X's and Y's lined up, almost like the ones place, the tens place, and the hundreds place, another way that you can isolate one variable is by eliminating one through combination. Okay, so what you're looking for is coefficients that when you add them or subtract them, they will eliminate. So I'm going to draw a line under here, and hopefully this will help you to see what I'm talking about. So I can think of this as an addition problem. And if I add this together, look what happens to my x's. I have a negative 2x and a plus 2x. Negative 2 and a positive 2, they cancel each other out. So one of the things I can do with a system of equations is I can line them up and I can add them. As long as I'm adding like terms, x's with x's, y's with y's, and constants with constants. So let's add these and see what happens. We have negative 2x plus 2x. There's 0 x's, so we don't have any x's. And I have negative 2y plus 4y is going to give me 2y. And negative 10 plus 30, and please use your calculators if you need to, is 20. Now I just have to solve for y by dividing by 2. And I end up with y equals 10. Now I know that this has one solution and I have the y value. So now I'm going to do the same thing I did with substitution, plug that y value back in to one of the equations to figure out the x value. So I'm going to use the red equation, 2x plus 4y equals 30. So 2x plus 4 times 10 equals 30, 2x plus 40. And I'm just solving this now because it's got one variable. Subtract 40 from both sides. I'm left with 2x equals negative 10. Divide by 2. And x equals negative 5. If you need to pause the video to copy this down or to really think about it, I want you to do that. So my ordered pair is negative 5, 10. That's the point where these two lines intersect. All right, so let's take a look at another example. So if you guys will write this one down, and again, pause the video if you ever need to. If we look at this one, my x's are lined up and my y's are lined up and my numbers are lined up, but I don't have the same or opposite coefficients here in order to eliminate the variables. So what I can do is I can multiply one equation. I don't know if you knew you could do that. So let's look. 3 and 5 won't easily turn into numbers that can be eliminated, but 4 and 2 can. You see how I can multiply this second equation by 2 and make this 2 a 4. So I'm going to multiply this by 2. I end up with 2 times 5 means I have 10x. 2 times 2 is a plus 4y equals 2 times negative 4 is negative 8. These are the equivalent equations. This one's just simplified. This one we multiplied by 2. But now if I write this one underneath, so I have 3x plus 4y equals 6. Now I see that my y's can eliminate. But instead of adding them to eliminate, I'm going to subtract them. So I have 10 minus 3 is going to give me 7x. 4 minus 4 is going to eliminate my y's. And negative 8 minus 6 is going to give me negative 14. Now, all I have to do is divide by 7, and I end up with x equals negative 2. So now I know I have one solution, and I know the x value is negative 2. Once I have that, I'm going to just do like we did with substitution. Let me take the blue equation. I'm going to solve that negative. I'm going to substitute that negative 2 in for x and then solve it to figure out what the y partner would be. Right, so 3 times negative 2 is negative 6. Now I have to add 6 to both sides. End up with 4y equals 12. Divide by 4. And we end up with y equals 3. So the ordered pair where these two lines will be intersect will be negative 2, 3. So if you feel ready to move on, you have a worksheet that you can work on today. If you would like to work with me, I am going to do a couple of these together just to make sure we understand. So on the worksheet, I'm going to do number 1 and number 5. So again, if you're ready to work on your own. You don't need to pay attention to what I'm doing if you're ready. Or if you feel like you want to work with me, we'll get this done together. Okay, so let's take a look at number 1. So number 1, I'm looking at 1 and I see that it's going to be too hard to move everything around to substitute. So what I'm going to do is I see that, oh, my x's are lined up, my y's and my numbers, and look, my x's are opposites. So I'm just going to add these up because they're opposites. So the x's disappear. Negative 2 plus 8 is 6y, and negative 12 plus negative 24, use your calculators if you need to, is negative 36. So now I can solve for y, and I end up with y equals negative 4. And then you guys know from substitution, it's the exact same thing. So I need to pick one of these to substitute it into. I'm just going to use this top one. So I have negative 4x minus 2 times negative 4 equals negative 12. So negative 4x, negative times negative is positive 8 equals negative 12. Subtract 8 from both sides. Negative 4x equals negative 20. Divide by negative 4, and we end up with x equals 5. So for number 1, the ordered pair is 5, negative 4. That's the solution. Now, you should probably be doing this work in your spiral because there's not a lot of room to do all the work, although your pencils are a little thinner than my marker. Okay, let's just try one more and then hopefully you'll feel really ready to do this on your own. So we're going to jump down to number 5. I'm going to clear my annotations. Pause the video, and this video will be on Canvas so you can rewatch it if you need to. But if we're looking at number 5 here, so first thing I notice is it's going to be really hard to set up for substitution. It's not really efficient. I'm looking at my x's, they're not going to cancel out. I could multiply by 2, but before I do that, I notice that my y's are both negative 9s. So they're the same number, but they're not opposites. So instead of adding them, that would give me negative 18. I'm actually going to subtract them. Here's where you may want to use your calculator because you got to remember these positives and negatives. So negative 2 minus negative 4 is going to give me a positive 2x. Check it in your calculator if you need to. Negative 9 minus negative 9 means that they cancel out because a minus and negative means we're actually adding it. And then negative 25 minus negative 23 is negative 2. Right? Now, we're going to just divide by 2. And we get x equals negative 1. So that's the x value of the solution. I can pick either one to substitute it into. So I'm going to pick the top one. Negative 2 times negative 1 minus 9y equals negative 25. With all these negatives, you just need to be really mindful. Use your calculator. Take your time. Negative times negative is positive. Then I have this 2 I need to subtract. And then we're going to divide by negative 9. And so y equals 3. So the ordered pair that is the solution to this system of equations is negative 1, 3. Hopefully you're feeling pretty confident to try these on your own. You can use the answer key to help you and find your good mistakes if you need to.